Good morning, everyone. Can someone confirm that my voice is clear? Okay, thank you very much. So shortly we'll be starting this session on machine learning. I'll just wait for a few minutes for Professor Nabil Houehi to attend. He's supposed to be co-chairing this session. In the meantime, let me just confirm that the presenters of the papers are present here. So we have the first paper coming up is Machine Learning and Omics Data for Predicting Overall Survival in Glioblastoma Patients. The presenter of this paper, can you make yourself visible, please? Okay, thank you very much. And next, we have Predicting Academic Performance, a comparative analysis of machine learning algorithms. The presenter, can you make yourself visible? Okay. And the third paper, binary and ternary human gait phase classification using machine learning algorithm. Can the presenter make themselves visible? Okay. Integrating machine learning with concrete science, traditional testing, and advanced predictive modeling. If you are the presenter of this paper, can you just raise your hand so that I can give you presenter access? Okay, thank you very much. Optimizing health through nutrition, machine learning insights from menopausal women. Okay. Okay, so I think we can begin. My name is Dr. Ali Ibrahim. I'm from the Department of Computer Engineering, University of Bahrain. I would like to welcome you all to this very interesting session on machine learning. We have 5 very interesting papers. This session will be recorded, so I'm going to go ahead and start recording. It's already recorded. Okay, so let's start with our first paper. Okay, so we have machine learning and omics data for predicting overall survival in glioblastoma patients. Okay, so we have Ms. Ishraq Al-Hashimi. Okay. Okay, so now you have presenter access. Okay. Ms.
Good morning, everyone.
Good morning and welcome. Now we have presenter access. Please go ahead, share your PowerPoint slides, and start whenever you are ready.
Okay, thank you. I hope you're doing good today. Thank you for being here. My name is Ishraq. I'm so excited to share our research titled Machine Learning and Omics Data for Predicting Overall Survival in Glioblastoma Patients, which was organized by Professor Nabil Ben Ammar and Professor Nabil Hajdi and I. So the glioblastoma is a devastating disease, so aggressive that even with advanced treatments, the median survival time is less than a year. This stark reality drives the need for innovative approaches to improve survival predictions and enable personalized care. Our study combines both machine learning techniques with omics data to address these challenges. Today, I will begin with an overview of glioblastoma and the challenges in predicting survival. I'll then explain our research methodology, focusing on how we integrated omics data and developed our machine learning models. Following this, I will present our results, discussing their implications for patient care and analyzing the key findings. Finally, I will conclude with future directions for this work.
Can I interrupt you for a minute?
Yes.
Your PowerPoint slide is still on the first slide.
Okay.
Yeah, now it's the introduction. Yes, go ahead, please.
Glioblastoma is the most aggressive and deadly form of brain cancer, classified by the World Health Organization as grade 4 glioma in 2016. This malignancy accounts for about 80% of all malignant gliomas. Patients with glioblastoma face a bleak prognosis. Without treatments, the disease progresses rapidly, even with advancement interventions. Most people succumb to the disease within 2 years of diagnosis, with a median overall survival time of less than 1 year. The study of glioblastoma involves two primary approaches, omics and non-omics. Omics technology include genomic, epigenomic, proteomic, and metabolomics that are used to analyze the genetic mutation, gene expression, and metabolomic pathways to identify potential biomarkers. On the other hand, we have the non-omic data, such as the demographic information, clinical records, environmental factors, and the brain imaging techniques like MRIs, CT scans, and PET scans contribute to a comprehensive understanding of the disease. However, the neuroimaging alone often struggle to distinguish between tumor and non-tumor regions. These limitations highlight the importance of integrating omic data to better understanding the biological process of glioblastoma and their impact on health. This integrated approach enhanced advancements in the survival prediction, also glioma detection and the treatment planning. In our methodology, we used data from CBio portal, which is an open access platform from Cancer Genomics. This portal provides comprehensive information on the gene expression, gene mutation, copy number alteration, mRNA, and DNA methylation, making it a valuable resource for cancer research and clinical applications. In our analysis, we used the glioblastoma multiform datasets, which initially contained 577 rows and 68 columns. After removing the irrelevant features, we refined the dataset to 12 K columns, which are grouped into two categories to enhance the analysis consistency and relevance. These datasets contain a variety of features, including the genomic features as the fraction genome altered and the mutation counts, as well as the clinical features as disease-free months and other non-genomic features. After collecting and importing the data, we performed several pre-processing steps. First, we dropped unuseful columns and removed duplicated records. We also filled the null values with 0. Since the dataset contain non-numeric features, we converted them to numeric values. Then we explore a variety of machine learning algorithms to identify the most accurate and reliable model for predicting the survival rate. Random survival forest, random forest regressor, gradient boosting regressor, XGB regressor, SVM for survival analysis, ridge regressor, and the lasso regressor. For the hyperparameter tuning, we use the grid search algorithm to optimize the model parameters by exhaustively testing specific hyperparameter combination to determine the optimal setting for each model. For the results, we evaluate the performance of our proposed models using the concordance index, the C index, which is a metric in survival analysis and the binary classification tasks. This table presents the C index achieved by each model, which can observe that the gradient boosting regressor showing the highest C index at 0.81. We can say that the GCIMP methylation status is a significant factor, influencing the overall survival in glioblastoma patients. Those with the GCIMP methylation phenotype generally have a longer median survival, making it a valuable prognostic marker. Its presence is associated with improved outcomes, suggesting a more favorable prognosis for patients exhibiting this phenotype. Evaluating the GCIMP status can play a crucial role in developing personalized treatment strategy, enabling more targeted and effective approaches tailored to individual patient profiles. The model achieved the highest C index at 0.81, demonstrating strong predictive power. Though other models performed similarly with C index values ranging from 0.78 to 0.81, indicating comparable effectiveness in ranking survival outcomes. This narrow range suggests limited variation in predictive feature within datasets. Consequently, criteria beyond predictive performance, such as interpretability to ensure clinically meaningful results, computational efficiency to reduce processing demands, and robustness to maintain stability across diverse datasets. This has become essential for model selection. To conclude, this research marks a paradigm shift in GBM studies by using omics data, paving the way for advancements in research and treatment beyond the limitation of traditional neuroimaging and biopsies. A key finding is the strong correlation between GCMP methylation status and the IDH1 mutation, underscoring the potential of omics data for enhancing survival prediction in GBM. This finding provide a foundation for developing more personalized and effective therapeutic strategy in the future. That was all. Thank you for your attention.
Thank you very much for this very interesting presentation. Now we have like 3 minutes for questions and answers. So I'll give the audience the chance to ask questions. So if you have any questions, you can just raise your hand, and I'll give you access to use your microphone, or you can type your question in the chat window. Okay, so any questions? Okay, Ms. Shaq, I do have a question. So you
Yes.
mentioned this C index as a metric for comparing the different algorithms. Can you elaborate more on the C index? How is it calculated, and why is it specifically used for comparison in this application?
As I said before, the C index is a metric used primarily to assess the performance of survival models in the context of time to event analysis. It predicts the probability of each person with the time, the survival time.
Okay, and you mentioned the best performing algorithm was XGB regressor?
No, the gradient boosting regressor.
The gradient boosting regressor. Is there a reason for this algorithm to perform particularly well? Is it the nature of the algorithm, or is it something else? Why is it performing better than the other algorithms?
Because it's used the ensemble learning method, and the ensemble learning methods give the better performance.
Okay, thank you. And just one last question: can you highlight like the future research work? Where are you intending to take this research further?
We want to predict the treatment planning, predict the survival time, also using the data that we have in our data set. We want to predict the treatments.
The treatments.
Yes.
Okay, great. Okay, thank you very much. Thank you. This was a very interesting presentation. Okay, so moving up, next is we have a paper titled Predicting Academic Performance, a Comparative Analysis of Machine Learning Algorithm. Is one of the authors present with us here? Please raise your hand. I'll give you presenter access. Okay, again, we have predicting academic performance, a comparative analysis of machine learning algorithm. Mr. Sayyid Al-Tabtabai is supposed to be presenting this paper. Okay. Okay, let's just confirm. So you might skip this paper and ask the presenter to present it later. Okay, so binary and ternary human gait phase classification using machine learning algorithm. Ms. Amal, are you present with us?
Yes, of course.
Okay, so I think we will skip the previous presentation. Can you just, whenever you are ready, just share your presentation and then start? You have 15 minutes for the presentation and 5 minutes for questions and answers.
Okay. Please, can you see my screen?
Yes, we can see your screen.
Okay, we can start?
Yes, go ahead, please.
Okay. Good morning, chairs and good chairs and everyone. My name is Amal Megni, and it's a pleasure to be here and present our work in binary and ternary human gait phase classification using machine learning algorithms, authored by me, Dr. John Narayan, and Professor Hassan Igritli. Here is an overview of what we will cover today. First, I will introduce the topic and provide some background information. Then, we will delve into the literature review to see what previous research has been done. Next, I will explain our methodology, followed by presentation of our experiments and results. Finally, we will wrap up with the conclusion. Let's start with our introduction. Walking is a fundamental human movement that requires the coordinated activity of our muscles, joints, and nerves. Understand how we walk can provide valuable insight into our health and mobility. Let's dive into the gait cycle, which is the repeated pattern of movement during walking. The gait cycle consists of two main phases: the stance phase, where the foot is in contact with the ground, and the swing phase, where the foot is not in the contact with the ground. The stance phase includes several subphases: initial contact or heel strike, loading response, mid-stance, terminal stance or heel off, and pre-swinging or toe off. Each of these subphases plays a crucial role in mechanics of walking. The swing phase, on the other hand, involves the foot moving through the air, divided into initial swing, mid-swing, and terminal swing. This is the picture of the different gait phases of a human walking and present the different subphases. Let's move why gait phase classification is so important. It plays a crucial role in three main areas. First, in clinical diagnosis and treatment, it helps clinicians diagnose and address gait phase abnormality and musculoskeletal disorder effectively. Second, in biomechanical analysis, it provides a crucial insight into joint motions, muscle coordination, and energy expenditure during walking. Finally, it's essential for monitoring disease progression by enabling healthcare progression and track changes in gait pattern over time. It aids in assisting disease progression and evaluating the effectiveness of treatment, particularly for conditions like Parkinson's disease, Alzheimer, and other diseases during stroke recovery. Let's move to the literature review. Gait phase classification using machine learning and deep learning techniques. For example, they are using the BBNN and NNN to estimate clinical gait mechanics. SVM, including Gaussian SVM, effectively classify gait phases and transition. ST-Deep Gait utilizes multi-layer NNN for robust gait recognition across different conditions. Also, there are also use the LSTM models demonstrate promising accuracy in estimate gait phases under varied conditions. CNN LSTM models effectively classify real-time gait trains, aiding in assisting device and gait analysis. And finally, they are using the machine learning technique like SVM, random forest, CNN decision tree models to personalize the gait signature for healthcare application. Now, let's move to our methodology. Let's take a closer look at the dataset involved in our study. The dataset we used comes from an existing source and includes information from 100 healthy adults aged between 21 and 79 years old. The data type we analyzed are diverse. We include demographic data such as age, gender, height, and weight, which help explain variation in gait. And additionally, we looked at detailed biomechanical, kinematic, and kinetic data, capturing the interactions of walking mechanics under various conditions. Our focus was a specific lower body movement, cover 10 different movements. This include hip, knee flexion and extension, as well as ankle dorsal and plantar flexion. For more detail, you can refer the study of Bahadouri et al. Or access directly to this link. This is the picture, present the left and right limb movement over the gait cycle. Machine learning techniques. In our study, we use 6 machine learning: KNN, logistic regression, support vector machine, decision tree, random forest, naive Bayesian. We adopted 2 training methods. The first method, we adopted a standard approach by partitioning our data into training and testing. 80% of the data set was allocated for training, and 20% of the data set were reserved for testing. And for the second method, we implement a participant-centric approach. 80% of individual was destined for training, and 80% for individual were reserved for testing. Let's move to experiments and results. This is the two table present the result of binary and ternary subphases. For the binary, with the first and the second method, as we can see, the stationary and random forest shows the height accuracy. And for the ternary subphases, KNN and the random forest shows the height accuracy via the two methods, first and the second method. This is the plot of the accuracy of the KNN algorithms from the binary and ternary subphases. And this is for the decision tree, also for the binary and ternary subphases. Finally, this is for the random forest algorithms for the binary and ternary subphases. This picture presents the confusion matrix obtaining via the first and the second method. As we can see in the first method, random forest shows the highest accuracy with 717 true positive and 111 for 41 true negative. And for the second method, around 756 true positive and 1126 true negative. This is the confusion matrix of KNN obtaining via the first method and the random forest obtaining via the first and the second method for the ternary subphases. As we can see, around 98% true positive as class 0 for the KNN in the first method, and the correct classify around 94% for the second method. And for the random forest is shows the highest correct classify around 97% as class 0 via the first method, and around 63% for the second method. Let's move to the conclusion. We evaluate machine learning algorithms for gate phase recognition using open source data from 100 participants. We compared two training methods from binary and ternary subphases. KNN decision tree and random forest consistently achieve the highest accuracy. The training method significantly influences algorithm performance. And for the future project, we focus on leveraging deep learning for more complex data set. This is some reference. Thank you, and thank you for attention, and any questions, please.
Thank you very much for this very interesting presentation. Now we have time for questions and answers. If anybody from the audience have a question, Ms. Amal, you do have a question? Mm-hmm. Go ahead, please.
Sorry, I can't listen to you.
Anyone has a question from the audience? Okay. So, Mr. Arif, you have access now to the microphone. Please go ahead and ask your question.
Hello, can you hear me?
Yes, we can hear you.
So you listed different methods, KNA, DT, and RF. Which of them provide the more accuracy?
KNN, random forest, and decision tree. There are for the binary subphases, we have decision tree and random forest show the highest accuracy. And for the ternary subphases, we have KNN and random forest show the highest accuracy, around 99%.
So all of them they are close to each other. They all above 90% accuracy.
Okay, thank you.
Thank you, Mr. Arif. Any other questions? Okay, I do have a quick question. You've already mentioned the data set, and you've provided a link for the data set. Can you just very briefly elaborate more on the data sets and what kind of features did you use? So you have already age, gender, height. What else for this kind of application?
Okay, Okay, in my dataset, I use the age. I use various age between 21 and 79 years old. I use also the gender. I use the female and the man. Different height, different weight. I use the other metrics of movement, like kinematic, biomechanical, like the movement, like time of the gait, like also the hip, knee, flexion, extension, and ankle dorsey, the flexion, the ankle between two subfaces, for examples.
Okay, great. So different kind of features. Okay, so the data set is available in this link
Yes, of course.
you've
Yes.
provided. Okay,
Mhm.
thank you very much. Thank you very much for this. Anyone has another question? Okay, thank you very much for this very interesting presentation. Okay, so now
You're
we can
welcome.
move on. Thank you. We can move on to the next paper. Let me just go back and check if Sayed Al-Tabtabai is present. So we have a paper predicting academic performance, a comparative analysis of machine learning algorithms. Is one of the authors present with us here? Please make yourself visible. Okay, so we move on to the next paper. We have integrating machine learning with concrete science, bridging traditional testing and advanced predictive modeling. Is any of the authors present with us here? Okay, so now you have presenter access. I hope so. Okay, Mr. Pukar, can you hear us?
Yes, Dr. Ali, I can hear you. I'm just
Okay, so
uploading my
whenever you
presentation.
are ready, whenever you
Yeah.
are ready, share your presentation, introduce yourself, and go ahead with the presentation.
Can you see my presentation, Dr. Ali?
Not yet. Not yet. We can hear you, but we cannot see your presentation yet.
I think it's not.
Yes, we can see your entire screen now.
Yep. Somehow it doesn't. I'll share with my screen. I think the window is not working.
Okay. Yes, we can see the presentation. You can put it in show mode if you want. Yeah, present.
Yeah. Good afternoon, everyone. My name is Pukar Shivakoti, and I'm a PhD researcher at University of East London, and I'm preparing this paper in behalf of Dr. Salim and Dr. Said. The title of this review paper is Integrating Machine Learning with Concrete Science, Bridging Traditional Testing and Advanced Predictive Modeling. Let's start with the introduction and fundamental. Machine learning enables a system to learn from data using algorithm to identify patterns and make decisions. It's also used deep learning uses neural network to process large data and improve tasks like image and speech recognition. Machine learning is used in the field like science, healthcare, robotics, and concrete research for optimization analysis. It also helps predict concrete properties, optimize mix design, and monitor structural health. Machine learning offers more efficient, accurate, and predictive methods than traditional concrete testing. Supervised learning, in this method, model are trained using labeled data set, allowing the algorithm to establish a relationship between input data and the desired output. In the field of concrete science, supervised learning is commonly applied to tasks such as forecasting compressive strength or determining concrete quality classifications. The second one is supervised learning. This focus on uncovering patterns and structures within unlabeled data. Clustering algorithm, for instance, can group similar concrete samples based on their properties, assisting in tasks like segmentation and classifications. Deep learning. This approach leverages multi-layer neural network to process and interpret intricate patterns within large data set. For example, convolutional neural network excel at the tasks like analyzing images of the concrete microstructure, while recurrent neural network are ideal for handling time series data from structure sensors. The key machine learning algorithms are decision tree, support vector machines, random forest, neural networks, TensorFlow, PyTorch. Data collection pre-processing is important. So the type of data for the concrete are physical properties, which include compressive strength, durability, chemical compositions like cementitious materials and aggregate, environment factors like temperature and humidity. These data are collected from either from lab tests, field tests, sensor network. The cleaning data after data collection data need to be pre-processed by cleaning data, handling missing values, outliers, normalizing, standardizing data scales, features engineering, selecting relevant features, creating new features. And the significance of data collection and pre-processing are to ensure data quality for accurate modeling, enhancing predictive capabilities, support optimization of concrete mix design, facilitate effective infrastructure management. The application in concrete regression graph for both the training and testing data highlight the strong predictive performance of the ANN model. The correlation results show a higher degree of accuracy with R square 0.966 for the training dataset and R square 0.97 for a testing dataset. This result demonstrates that the ANN model is highly accurate and reliable in predicting the 28 days compressive strength of rubber concrete. This model holds significant promise for developing numerical tools to estimate the hardened properties of rubber concrete. Models predicted values with experimental results with green highlight prediction with an error exceeding 20%. For the 6 models in the right side, the error between the prediction and actual value is generally below 20%, indicating a high level of prediction accuracy. This demonstrates that regression modeling can effectively complement experiment data and support engineering applications. So application is concrete science, is quality control and monitoring. Machine learning helps quality control in concrete using data and algorithm for prediction and optimization. It also predict concrete strength and durability based on mix proportion and curing times. It also machine learning monitors concrete in real time, detect anomalies and optimize mix design for performance and cost. Machine learning analyzes sensor data to predict maintenance need and improve structural health monitoring. Machine learning also in case of optimization of mix design, it helps it improves concrete mix design by analyzing data to predict properties of different mix combination. It replaces trial and error by identifying patterns in historical data to optimize mix properties like strength, workability, and durability. Machine learning also considers environmental factor and project needs, optimizing the use of supplemented cementitious materials to reduce the carbon footprint. It also minimizes physical testing, saving time and resources while ensuring high quality, more durable concrete structure. in terms of structural health monitoring, it enhances structural health monitoring by analyzing real-time sensor data on strain, temperature, and vibration from concrete structure. These models detect pattern and anomalies, identifying weakness like cracks, corrosion, or excess loading. Machine learning based structural health monitoring system provide early warning, enabling timely maintenance and exceeding the lifespan of a structure. It integrates data from IoT device, drone, and satellite image for holistic view of structural health, improving safety and reducing maintenance cost. In its application in failure prediction and risk assessment, machine learning has improves failure prediction by analyzing data from maintenance records, sensor, and environmental factor to detect patterns leading to structural issue. These models like machine learning models like neural network and decision tree predict failure likelihoods such as crack or corrosion using real-time data and future future performance forecast. It also helps more accurately measure the do the risk assessment, quantifying failure probability and consequences, allowing for better prioritization of maintenance tasks. Challenges, and here are some challenges and limitations. The challenges, first primary challenges is data quality and availability. The quality and consistency of concrete data can be inconsistent or incomplete, making it difficult to train reliable machine learning models. The black box nature of some machine learning model like deep neural network complicate understanding and trusting their prediction in safety critical applications. Implementing machine learning in concrete engineering requires integrating with existing systems and ensuring real-time performance, which may need lightweight model or distributed computing. Machine learning model can be computationally intensive, and balancing accuracy with efficiency is essential for practice real-time deployment in concrete science. Future trend and innovations in machine learning in concrete science. Machine learning combined with the IoT device and sensor network enables real-time data analysis for optimized maintenance and failure prediction in concrete. Machine learning framework will improve material characterization by integrating data on composition, construction method, and environment factor, enhancing concrete property predictions. Explainable AI techniques will improve trust and transparency in machine learning models, helping engineering better understand prediction and make informed decisions. Machine learning will transfer constructive practice by enabling more accurate mixed designs, supporting sustainability, and improving infrastructure performance. Ethical considerations, ensuring data privacy, security, and proper consent is crucial while when handling sensitive concrete science data related to material properties and structural integrity. Addressing bias in training data and algorithm is vital to prevent inequitable outcome in infrastructure design, maintenance, and risk assessment. Establishing clear explanation and auditing mechanism for machine learning models is necessary to build trust and ensure safe, reliable, and ethical decision making in concrete science. Societal impact and benefit. Machine learning improve concrete mixed design, leading to more durable structure, reduce environment impact, and great resource efficiency. Machine learning structure health monitor helps detect early sign of deterioration, and improving safety and reducing risks to public health and infrastructure. It also optimizes construction practice, reducing cost and improving efficiency, making infrastructure more accessible and affordable for community. Here are some concluding remarks. Machine learning techniques improve predictive modeling, mixed design optimization, and structure health monitoring, enhancing both research and practical application in concrete science. Issues like data quality, model interpretability, and scalability must be addressed to fully utilize machine learning in concrete science for better accuracy and real-time quality data control. Future work should focus on integrating IoT, advancing explainable AI, and addressing ethical concerns like data privacy and fairness to improve infrastructure resilience. Collaborative effort among researchers, engineers, and industry stakeholders are key to driving machine learning innovation in concrete science, promoting sustainability and improving safety. Thank you very much for your time, and I'm happy to take some questions, and apology in advance if I could not answer some question. I will make sure that it will be passed on to the author and to the organizer. Thank you very much.
Thank you very much for this interesting presentation. I will leave the floor for the audience to ask questions. So anyone from the audience has a question, please raise your hand and I'll give you access to your microphone. Okay, I do have a question.
Yes.
So you mentioned that in the future plans you're planning to integrate IoT for real-time monitoring of concrete structures.
Yes.
So how are you planning to do this? I mean, so you're going to connect sensors and to measure.
Yes.
So what kind of parameters are you going to measure?
Yes, actually, it's not actually the plan. It's a future trend, and actually, you're right. The sensor in the structure, in the building structure, if there will be the sensor, it will be collecting the data of the structure, strain data, or any deformation data in real time. So it will be helpful to take action earlier. Yeah. It's all the sensor will be attached to the structure of any building.
Okay. And also I can see that it would be difficult to collect data for this application. I mean, was this a challenge for you collecting the data set?
I can't answer that because it will be challenging for the author, definitely. So yeah, it will be challenging for the author.
Okay, I wish you best of luck. Thank you very much for your presentation.
Thank you, Dr. Ali.
Thank you.
Thank you.
Thank you. Okay, so moving on, let's just check. So we have this pending paper, Predicting Academic Performance, a comparative analysis of machine learning algorithm. Did any of the authors join us? Predicting academic performance through machine learning. Okay, not yet. So I think we just have to move on to the, I think it's the last paper now. Optimizing health through nutrition, machine learning insights from menopausal women. If you are one of the authors, if you are the presenter of this paper, please identify yourself. And I'll give you presenter access. Okay, again, optimizing health through nutrition, machine learning insights from menopausal women. Okay, so we don't have any of the authors to present the paper. So what I can do, I can thank all the authors who presented their papers. I will leave the session open in case authors of the remaining paper do attend. So you're free to just join again in case some of them show up. In the meantime, I would like to thank all the presenters. Okay, we do have. Okay. Hold on.
Can I share my PPT?
Okay, which paper are you going to present?
Logopriya, sir. Optimizing health through nutrition, machine learning insight for the menopausal.
Okay, please go ahead. Share your PowerPoint slides and start whenever you're ready.
Can I start, sir?
Okay, share your PowerPoint slides, please.
Can, yes. It's visible.
We can see. Yes, we can see your presentation.
Okay, sir. Can you start, sir?
Okay, please start whenever you are ready.
Okay, sir. Good afternoon for everyone. So myself, Logo Priya. My co-authors are Surendran R and Sundara Rajulu, Navanitha Krishnan, and Apudarai. So these are all my co-authors. In my paper title is Optimizing Health Through Nutrition Machine Learning Insight for Menopausal Women. These are all the content, introduction related to work and proposed work. So in this proposed work, data collection, pre-processing, and the extraction, preparations, and the measures and nutrition recommendation. They based on the result analysis and performance analysis with professional model, and conclusion and future direction with the references. In this paper introduction, so we'll be focusing on the women's health and nutrition. In this women's health and nutrition, based on the healthy food nutrition, sustainable nutrition essential for the sound life, and food constrained nutrition for the growth and maintenance of the well body and well maintenance of the nutrition optimal growth. It will be developing in the sustainable energy for everyone. In this choosing the menopausal phases, it's both postmenopausal and menopausal are conditions which is woman is unable to experience the menstruation. In these conditions, to manipulate it's between the ages of 45 to 55, they will be getting to the in these menopausal stages. In these menopausal stages, with the machine learning algorithms, we will be developing the these are all the models, the regression model and classification model. In these regression models, using the techniques and algorithms to identify the relationship between the variable and predicting the outcomes. In this classification model, supervised learning techniques to use the algorithms categorized by the predictify the classes and classified models trained using the label to input the data and evaluated in the test data. In this parameter, we will be applying to the collaborative filtering and content-based filtering and based on the personalized recommendations. In this collaborative filtering, it will be generated to the recommend according to the ratings and user items likely the appropriate matching for the nutrition suggestions. In this content-based filtering, recommendation based on the content-based, which is a collection of user data regarding recommended items and information about the various type of food nutritions. In this based, we will be developing to the personalized recommendation based on the finding the model's content and based this collaborative filtering algorithms to employ the users and generated to the specific recommendation according to the this menu for the user profile. In this process, evaluated to effectively in this recommendation system sustainable using these methods. In this literature survey, the first paper, it will be methods can be used in the knowledge-based system. It will be nutrition recommendation using the during the menstruation cycle. In this parameter, it will be made to this method of knowledge-based system. In this second paper title is it will be qualified helping to the nutrition suggestion that methods can be used for the quantitative studies and giving to the help of tools and then teenage girls they will be scoring the pain of menstruation in this backup in the during during the menstruations. In this next paper, it will be menstrual bloods and linked in this during the menopausal. That method can be biochemical analysis based on in these benefits providing to the insight into the possible treatment action to it established like between the reducing the gynecologists evaluated in this menstruation blood losses and in this next paper in this during the menstruation and this decreasing the methods of commentary process that based on the important cost of the menstruation hygiene processes. In these papers are in this first paper it will be during the children's based on the premenstrual and the onset of puberty. It will be methods can be longitudinal studies and this in this benefits of persons vulnerability affecting earlier life of stress and premenstrual ages the maturity in this onset of puberty. In this next paper, it will be knowledge and attitude based on the curriculum guidelines, how they will be developing this methods of educational interventions. In this education interventions, it's based on the implementing guidelines, which is raise the knowledge of the condition. In this next paper, it will be planned based on the dietary, and girls it will be menstrual ages, that based on systematic review they will be collected. These are all the methods based on they studied and planned based on through the women's have menstrual in these basic parameters. Next, in these collaborative filtering algorithms to mobile meals and ordering to the suggestions app, how they will be collecting to the filtering algorithm, then applying to this food order menu, then recommended it will be showing to the based on the request, and it will be showing to the result. This during menstrual cycles and the hybrid recommendations, it will be women health nutrition might be implemented in these methods of hybrid recommendation system. It will be benefit for the designed for the during the women's menstrual cycles, offering the combination of dietary recommendation. It's help to the they'll be staying healthy. In this workflow of the proposed work, we will be collecting to the data, and after that we will go for the pre-processing based on the given parameter. And future engine, it will be collecting to the extract the collected data, then evaluating and modeling training for based on the regression model and classification model. In this regression model, we will be applying to the linear regression, logistic regression, and R squared. In this classification model, SVM and random forest and RUC and Ragose. These are all the based combining the model of personalized recommendation. It will be using the filtering method of collaborative filtering, content-based filtering, and MAA RMSE. It is recommended for predicting the data. Finally, you will be getting to this recommendation. The menopausal dietary recommendation in this present the menopausal cycle related to the health, such as the menopausal problems, well suitable to the promoted specific level of NHANES complexity related to the woman's health. In this paper proposed work, it will be data collecting to the success by the pre-processing. We are missing the values are handled the number of scaled as well as it can be replaced in this several way of instead of the forwarded to the imputational and normalization is performed with the help of standard scales with the by the formulation. It will be techniques categories the converted to the one hot encoder represented by the zeros and ones. Each category is described by the binary characters. In this collaborative filtering, analyzing the behavior during the menopausal and utilizing the preference and expressing through the suggestions and rating other activities in this parameter user item and rating matrix representing user preference and aspect of the related to the menopausal. In this, every evaluation similar to the across user profile and this system generated user cluster and based on the similar tested interesting during the menopausal. In this, applied to these materials and cannot be easily defined, making this facility for addressing menopausal health issue that based on only we will be developing in this concept. In this concept too, next we will be applying to the content-based filtering, evaluating to the recommended based on the overall structure, user preference and interactions, developing the profile items and identifying the similar items representation individually preferences and pre-processing data set before modeling the training and efficiency of the reliability, including the samples and relevant and data and extracting the significant concept related user preference based on the user preference. In this process, data before using the determining the according to the elements and the effective recommendation, user makes decision based on the data and promoting personalized recommendation in this future. In this data collecting and pre-processing, data collecting to the approaches of the medical records and surveys and health tracking based on the apps, it will be gathering the information from several sources and the gatherness of the through include for the collecting of the all the data. In this data column, symptoms, incidents and the heart rate and body temperature, sleep hours and dietary habit. This based on the collecting consent, essentially health indicated in this formatted. Data pre-processing, forwarded filter, and the imputations addressing issues and missing the values order assures the completeness of the data. In this normalization, we will be using the standard scal coder and the normalized numerical values to the unified scal and encoding to the one hard encoding, transferring to the categories variable into the numerical representations. In this model type, we will be using in the models of regression model and classification model, recommendation model. In this based on the parameter algorithms, linear regression and logistic regression, through using performance, describe the developing evaluation model to the focused and numerical outcomes. This classification models, SEM algorithm based on the performance through using this development access to the model category outcomes based on the presentations. In this recommendation model, collaborative and content-based filtering through using these performance metrics and describing the general customized suggestions and access their precisions. This personalized suggestion to using the recommendation algorithm through the based on the finding the model and content-based and collaborative filtering algorithm applied to the user genetic specific recommendation according to this universal user profile. In this process to evaluate effectiveness, these recommendation systems to statistical measure commonly used for the MAE and RMSE. So in this precision effectively customized recommendation engine models forecast as assessed with the mean absolute error and root mean squared error. So software testing will apply to this Python 3.7, other applications of artificial intelligence, such as the OpenIA Python and many others. In Intel Core i5 CPU process and 12 GB of RAM and 2 GB of graphical card, and we are used in this conducted test. In this evaluation, first we will be represented for the individual model performances, then combined model performances of the regression model and classification model, then recommendation model. In this performance, all overall machine learning algorithm performance, it will be showing to this diagram. So conclusion, in this work present pipelines, it will be superwoman support to the women's health and focusing on the menopause dietary recommendation, utilizing the comprehensive data set which indicates symptoms and intensity, heart rate, body temperature, sleep duration, nutrition data from medical records, questionnaires, and tracking the apps during the menopausal time and menstruation content. It will be based on the in this data, it will be pre-processed, include further missing the value standardized and the numerical data and the encoding categorical data. In model linear regression and logistic regression and SVM and random forest evaluation with logistic regression of achieving 95% in this accuracy of the classification to using the recommendation generated through collaborative and content-based filtering through using these are all the models. And this future work we will be planning to direct to the indicating of the real-time data from variable leveraging advanced AI model like deep learning and implementing reinforcement learning for adaptive recommendation, expand to the user feedback will further personalized and optimizing health intervention. And these are all the in this paper reference. Thank you.
Thank you very much for your presentation. So I'll leave the floor for the attendees. Anyone has a question? Anyone has a question? If you have a question, please raise your hand. I will give you access to the microphone. Okay, I do have a quick question. So did you consider what kind of user interface your system would have eventually? So are you planning to integrate this in a mobile app or a wearable device or anything like this?
So in this user preference for 45 to 55 ages only, they will be get to this menopausal duration. That time only they will know that what are the symptoms and problems they will be facing. That time we will be collecting to the survey and collecting to the medical records and all the things. That after that we will be collecting what are the measurements we will be applying to this heart rating and sleeping hours. It at all the things. It is based on in this based on we will be finding the symptoms. After that only we will be giving the suggestions for the
Okay, so you're planning to integrate wearable devices as well in the future?
Yes, sir.
Okay, great. Okay, that's it for me. Thank you very much for your presentation.
Thank you so much.
Thank you. Best of luck. Thank you. Okay, so one final call we have one paper I think it's predicting academic performance, a comparative analysis of machine learning algorithm. So anyone of the authors here? This is the final call for this paper. Okay, so I just want to thank all the authors, all the presenters for their interesting presentations, and all the attendees. We still have many interesting sessions in this conference, so hopefully I will see you soon in the remaining sessions of this conference. Thank you very much from me again. I'm Dr. Ali Ibrahim from the University of Bahrain. Thank you very much, and I'll see you soon in the remaining sessions of this conference. Thank you very much.
Thank you, Dr. Ali. Thank you very much.
Thank you.
Thank you, sir.